Hi everyone, good morning. Am I audible?
Yeah, ma'am, you're audible. Good morning, ma'am.
Good morning, ma'am. You're audible.
Okay. Okay, so you had one session for weeks 5 and 6, right? Revision session.
Yes,
Yeah,
ma'am.
Okay. So we'll discuss 7 and 8 today and mostly we'll just solve problems. Okay. Uh, let's wait for 3-4 minutes. Other people join, then we'll start at 9:05. Okay.
okay, ma'am.
No, అసలు
Okay, so let's start. So before we start, see, in quiz 2, there will be around 50 to 60% weightage from weeks 5 to 8. Okay. Now, among these weeks, weeks 5 and 6 are very important. And I hope you have discussed questions from those, right, in the previous session.
Yeah, ma'am.
Yes, ma'am.
Okay, so whatever questions are discussed, just follow those. That is enough. And from week 7, mostly like 1 or 2 questions at max can come, but also you are not going to have to write the entire code or anything like that. Okay, so just like basic questions, maybe a little bit of theory questions. So okay, let me ask a few. So what is the module that we need to import in order to establish connection? Database,
Psychopg 2.
right? Psychopg 2. And okay, can anyone tell me the difference between fetch all and fetch many?
Fetch all fetches all the rows at once, but fetch many fetches the number of rows that is given as argument for fetch many.
And if I don't give an
If we
argument,
not
then
give argument, then it will fetch only one row.
Yeah.
right. So this type of questions might come. Okay. So one more thing, like let's say I want to insert some rows into the database. Okay. So along with the insert statement, so you all learned about commit, rollback, these, right? So if I don't issue the commit statement, then what will happen? Like I wrote the entire code, but I didn't write the con.commit. Then what will happen?
Ma'am, the row will not get updated for the database inside the database.
So that will not get updated in the main database, right?
Yeah.
Similarly, if I do any update or delete any commands, okay, and I don't write the commit, then it will work for that connection. Like at that point, it will work. You'll get the query result, but it will not reflect on the original database. What is rollback?
To undo whatever has been done. I mean,
So
whatever changes
rollback.
have been done till the until the last commit. Yeah.
So if I have issued commit statement already, can I then issue rollback?
No.
So that can be done only before the commit is issued, right?
Yes.
Yes.
Okay. So this is the type of questions you can get. Okay. Okay, let me share the screen.
And ma'am, questions related to HTTP and HTML, those things.
No, like all that theory part that is given, you can go through it once, but mostly this type of question will only be asked, like what has been discussed in the week 7 session also.
Okay,
That is
ma'am.
enough. All right, is my screen visible?
Yes, ma'am.
Okay. ER diagram, yes, of course, ER diagram questions will be there from week 4. Weeks 1 to 4 also, don't leave it, okay? 30 to 40% questions are going to be from there. Especially week 4, week 3, week 4, the SQL part, ER diagram part, relational algebra, calculus, these things are important. Okay. So this is the first one.
Ma'am,
Yeah.
so it will be based on the previous year questions paper.
Yeah, previous year papers, if you solve, you'll get the pretty much idea like what type of question might come. Now, of course, some questions will be different, but yeah, the overall pattern is more or less same. See, like this is one of the questions from all of the questions in this slides that we are going to discuss today. They are from previous years only. Okay, previous year quiz to end term questions. So see, in Python Postgres database connectivity, cursor.fetchMany method is used to retrieve data from a table. Method cursor.fetchMany returns what? So what does it return?
List of
Dictionary
tuples.
tuple, list of tuples. Right. These are like very easy questions. See, for this there are 2 marks. Then
Ma'am, if there was a fetch all written, then what will be the output?
fetch all. Fetch all
Yes.
means it will again give you the list of tuples only, but all of the tuples. Okay, and in fetch many you can specify in the argument that how many tuples you want. If you specify 5 inside this bracket, then the first 5 rows will come. If you don't specify anything, then only the first tuple will come. Okay.
Okay, ma'am.
Okay. See this one. Read this question. Okay. So this student table is given to you. It is saying after executing the Python code below, it is observed that the new tuple didn't get updated. So you have to check the code and find out possible error and write it down. So this is the code. Now all of you are familiar with this type of code, right? I mean, this template was given to you in the week 7 session.
Yeah,
So
ma'am.
this is how you have
You
to
need to
write
make
it.
it a little bigger, ma'am. Sorry.
Yeah,
Thank you.
this is okay.
Yes, ma'am. Thank you.
See, in OPE exam also there will be 2 questions from Python DB, right? And both of these are going to follow the same format. But obviously you can't copy paste this, so you have to know these, right?
Yeah, ma'am.
So what is the error? It is saying that I want to insert a new tuple, but it is not getting updated in this table. Why is it not getting updated? What is missing?
We are not committing it
So that statement should come where?
before closing the cursor.
This one, right? So write down
Yeah.
the code here. So what will I write down here?
Connection.commit.
This, right? If I don't do this, then here I am writing, okay, what is cursor?
Cursor is like a pointer.
Like an object, right?
Yeah.
And, okay, what else? Okay, why do we have the try except these blocks? What are they used for?
Ma'am, just to overcome the errors.
Right, just to overcome errors. Okay. So pretty much all of these you know. So only this con.commit is missing. That's why the change will not be reflected. So that's the answer. Okay. Now from week 7, I am saying that this type of question will only come. The code will be given to you. Maybe 1 or 2 lines are missing. You are going to have to say what is missing or what is the error. Okay. That's it. So no need to memorize all that theory on web technologies and everything. So just go through the week 7 session once, and if you want, go through the lecture slides once. That's it.
Okay, ma'am.
Okay. So week 8, we will discuss some questions from there. See this one. So consider a sequence of pending block references in the given order. So this is the order of in which blocks are coming. Okay. This is what type of question from which topic? Buffer replacement.
Yeah.
Right? So the system has a buffer with 4 slots. Assume that initially buffer is empty. If the least recently used LRU buffer replacement policy is used, then how many misses or page faults will occur while referencing? Misses means what? That the page that I am trying to access or reference, that is not present in the buffer, right? That means that's a miss. If it is present, that's a hit. So to solve this, what do I have to do? I have to write all of the steps, right? That I have to insert all of these references one by one.
Yeah.
So first draw the buffer with 4 slots. Okay. So first reference is what? Page 4. So that will come here. Okay. So is this a hit or a miss?
Miss.
Miss.
This is a miss. Okay.
Excuse me, ma'am.
Yeah.
The first page should be written at the top or at the bottom?
Anyway, you can write if. Did I do this before with bottom? Like it will
Yes,
start
ma'am.
with bottom. Okay, fine.
Yes,
Let's
ma'am.
do that. No problem.
Ma'am, we can do this by horizontally.
Yeah. Anyway, you want just keep the order correct. That is all.
Okay.
Okay. First 4 came. That's a miss. Then there is 3. Okay. So
Miss.
3 will come above 4, right?
Yes, ma'am.
Yeah.
So 4 becomes the least recently used. So this is also a miss because 3 was not present. Then 1. This will be a hit or a miss.
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 So basically, whenever the buffer is empty and you are inserting new blocks, they are all going to be miss. 3,
Yes.
1. Okay. So this is also a miss. Next is page 4. This is what?
Hit.
Hit.
What will the buffer look like now? What is the least recently used block?
4
3
1.
is not.
What is the least recently used page at this point?
4.
3.
3.
3.
See, 4 was last accessed now, right? So 4 comes to the top now. 4 will be here. 3 will be at the bottom and then 1. Okay. So just this part will move down, and since 4 was last reference, so it will go up. Because it is LRU algorithm, right? So least recently used will stay at the bottom. So this is a hit. Okay, next is 7. 7 is hit or miss.
Miss.
Where will it go?
At the top.
So this will be 3, 1, 4, 7. This is also a miss. Okay, this 7 is done. Next there is another 7. This is what?
Hit.
Will the order change?
No, ma'am.
This will remain same. Okay.
Yeah.
This is a hit. Next we have 1. This is hit or miss.
Hit.
Hit.
Tell me the order starting from top.
1743.
So 1 we
1,
accessed, right?
7,
So
4.
1 will come. Then 7, then 4, then 3. Correct. So this is also hit. Next we have 4. This is
Again
hit.
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 Tell the order.
4173.
So 4 will go to the top now. So
Yeah.
4, then 1, 7, 3. Rest of the blocks remain in the same order. Right. This is also hit. Next. Next we have 5. This is a
5,
miss.
4,
Right.
1, 7. Yeah, miss.
So this miss. So which one will I get rid of? The least recently
3.
used block, that is 3. So 5 will come on top. Then 4, then 1, then 7. This is a miss. Next 2. 2 is also a miss.
Yes.
I'll get rid of 7.
Yeah.
So this will be 2, 5, 4, 1. Next is 3. Again miss. So it will be 3, 2, 5, 4. Next is 4. Now tell me the order. This is a hit.
Hit. 4, 3, 2, 5.
So 4 at top, then 3, then 2, then 5. Then 7. 7 is also
Miss.
miss. So it will be what? 7,
7,
4,
4, 3, 2.
3, 2. Next is 4, which is
Hit.
again hit. So order changes to 4,
4, 7, 3, 2.
7, 3, 2. Next is, this is done. Next is 2. So 2 is hit. 2 is present. So 2 comes to top. 2, 4, 7, 3. Okay, next is 4 again.
4,
So
2,
4
7, 3.
will come. 4, 2, 7, 3. This is also hit.
Hit.
Next we have 1. So 1 is hit or miss.
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 That will come where? On the top. Then
Yeah.
Yes.
4 to 7.
4, 2, 7.
Next we have 4. Hit or miss.
Hit.
Hit.
So 4 will be on top now.
Yeah.
4, 1, 2, 7. Okay, next is 2. 2 is also hit.
Yes.
Yes.
This will be 2, 4, 1, 7. And last reference is 5. That is hit or miss.
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 So which block will be removed?
7 will be removed.
So 5, 2, 4, 1. Correct. So now calculate how many misses are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 misses. So 10 is the answer. So this type of question you are comfortable with right now.
Yeah, ma'am.
From LRD only this type will come. Okay, nothing else. Or maybe they will ask what is the difference between hit and miss. Like H minus M, number of hits minus number of miss. This might come. Same thing. As long as you know how to find hits and miss, you can solve. So this is saying following numbers are inserted into
Just show it for a minute, please.
Yeah.
Thank you, ma'am.
Okay. See, next question is saying following numbers are inserted into an empty binary search tree in given order. Okay, X and Y denote number of nodes in left and right subtree of node 86. So we have to find the value of X minus Y, absolute value. So for this, we have to create the tree first, right? So what is the root node?
76.
76. 86 will come, right of 76.
In the right.
42 will come,
Left of
Left of 76.
112 will come,
Right of
Right of 86.
86.
120,
Right of 112.
Right of 112.
21,
Left of
42.
78,
Left of
Left of
86.
left of
86.
86.
78 is greater than 76, so
76.
definitely in right subtree, but less than 86, so left
Left of
subtree of
86.
86. Yeah. 38,
Right of
Right
20.
of 21.
right of 21. 45,
Right of 40.
Right of 40.
80,
Right
Right
of
of
78.
78.
77,
Left of
Left
78.
of 78.
and 79. Last
Left
one.
of 80.
Left of 80.
So 79 is greater than 76, so right subtree, but less than 86, so left subtree. Then again, greater than 78, so right subtree, less than 80, so left subtree.
Left
Yeah.
of 80.
This is the tree. So now node 86 is here. It is asking X is number of nodes in left subtree. The left subtree is this part, right? How many
Excuse
nodes are
me,
there?
ma'am.
4. Yes.
Ma'am, how can start 76? How can start from 76?
Because 76 is the first node given in the sequence. No? So following numbers are inserted in the given order. So in this order only you have to insert.
Then there is no need of sorted.
No, you don't need to sort. Whatever order is given in that order you will insert.
Okay.
Sorted tree will anyways give you a skewed tree. That is not a good tree. It will not be a balanced tree. Anytime we insert nodes in sorted order, the tree becomes skewed. That is, it will give you maximum height. So, okay. So 86 left subtree, how many nodes are present? X is equal to
2.
4.
4. Right subtree, Y is equal to
2.
2. 2.
this 2. So X minus Y will be 2. So this option. Okay, this is clear for everyone?
Yes, ma'am.
Yes, ma'am.
Let's see this one. Which of the following are correct about a linked list? The linked list can store data. Linked list stores data in contiguous memory locations. Is this true?
No. No.
So this means what? That not all the data, like after head.
Ma'am,
node,
I have a
after
doubt.
second node. In which question?
Ma'am, in the previous question,
Which
can
one?
you explain the last part, how you get to?
Yeah, see, X is what? X is the number of nodes in left subtree of node 86. So this is node 86.
Yes,
This is its left subtree. This
yes,
block that I have made. So how many nodes are there? 1, 2, 3, 4.
4.
And Y is what? Number of nodes in right subtree. So this is the right subtree. How many nodes are there? 1, 2.
Okay, ma'am, got it. And ma'am, what is queue and a stack?
Queue and stack. Okay, I'll explain. I have a question on that. First, let's
Okay.
answer this. Okay. So linked list, what happens that all the nodes are linked. So they can be stored anywhere in the memory location because after every node we have a pointer, right, to the next node. So wherever we store it, we can approach the like second node, then third node like this. So it is not necessary to store it in continuous memory locations. Can array be stored in continuous memory locations or discontinuous?
Yeah, array is stored in continuous memory location.
Array has to be stored continuously, right? Because there are no pointers associated with any node.
Yeah.
So this first one is false. The linked list can be stored anywhere. Each node contains a link to another node. This is correct.
Yeah, true.
Right? So each node structure is like what? There's the data part and there is a link part, right? This is the structure of a node.
Yeah.
Allows random access using index, which is fast. So is there an
False.
index?
No.
No.
So random access is not possible in linked list, right? You have to go using the link like one after another. That only you have to do. No random access is allowed. So this is also wrong. Flexible in size.
Yeah.
This is correct. So B
Ma'am,
and D are
how
correct.
flexible in size?
Sorry?
How it is flexible in size? I mean,
Flexible, that means you can add however many nodes you want, wherever you want to insert. You can insert between any two nodes or delete any node you want. Right.
okay.
And
Okay.
flexible in size means also the memory is allocated when you allocate a new node. You don't have to allocate memory in the beginning. Like in array, we have to say that, okay, I need 10 memory locations for this array. So in the beginning only we allocate the memory, right? But in linked list, you don't have to do that. Every time you, what can I say, initialize a new node, then only the memory is allocated. Okay. So no wastage of memory.
Ma'am, why the first option is incorrect?
Because linked list, the nodes are like this, right? This is one node, then this is another node, like this they're stored. But these nodes are not stored one after another in the memory. If this node is stored in, let's say, memory location 1000, then this node can be stored in memory location 2000. Okay, instead of 1001. So every node in the linked list can be stored anywhere in the memory because all the nodes have the pointer to the next node. So no need to store them continuously in memory locations. Okay.
Okay.
Ma'am,
Yeah.
ma'am, arrays won't be flexible in size, no?
No, array first only we have to allocate the memory, right? Whenever you initialize an array, you write the size of the array. So if you know C programming or Python, whatever, in Python we use list. So in C, whenever we initialize an array like this, if I want to have an integer array, so I'll write int array and I have to write the size, right? So this memory is allocated in the beginning. But in case of linked list, what happens? I don't know. Every time I allocate a new node, then only the memory for that node will be allocated. There is a statement called malloc, okay, memory allocation. So that statement is issued every time a new node is initialized. That is flexible in size. Clear?
Yes, ma'am.
Manideepa ma'am, for week 7 you have already finished.
Yeah, week 7, whatever I said, like that are the only 2-3 kinds of questions I could find in previous year also, because not many questions are asked from there. Okay. So for week 7, just going through the session once is enough. Whatever session Piyush sir took, that is enough.
Okay, yeah, accumulate. So, okay, ma'am.
Okay, and like go through the slides, but no need to memorize that whole HTML, web technology, those theory parts. Okay.
Ma'am, for the wrong option C, what can be the question, ma'am?
Allows random access.
Yes, ma'am.
So in linked list, random access is not allowed, no? How can you randomly access a node? You don't know the
No, what can be the
index.
question? What can be the question I'm asking? To make option C correct. So this is wrong for linked list. I agree.
Yeah.
But what can be the right question for option C? Is there a right question for option C?
Right question in terms of linked list, you can't write. Like in terms of linked list, option C will not be correct.
Agree.
So random access is possible where?
Okay.
Where is random access possible? So you need to know such data structures.
In array.
In array, random access is possible. Why? Because we have indices.
Okay.
All right.
Ma'am,
Hmm.
likewise, what are the linear structures of flexible in size? Actually?
So in linear data structures, you people only have these two, right? Array, linked list, and stack queue. These things. So stack and queue are also pretty flexible in size only. I mean, you don't have to allocate the memory in the beginning. See, have you done the code for stack and queue?
No, ma'am.
Okay, so let me show you that once. Okay, I'll discuss that part. But mainly, array is flexible in size. Array is not flexible in size, but linked list is flexible. So if you ask for linear data structure examples, so one for flexible is linked list, one for not flexible is array. One second, now I'm getting a call. Just a second. Yeah, okay. What was I saying?
Yeah, one example for.
Yeah, right. So stack and queue you're asking. So stack and queue are both flexible. Okay.
Okay.
They can grow and shrink according to whatever your requirements are.
Okay.
So if you haven't done stack and queue, let me just give you a little idea of what it is. So stack is what these are all implemented using array only. Okay, stack, queue, these are implemented using array. You can also implement them using linked list, but mainly array is the easier implementation. So in case of stack, what happens? Stack is such a data structure which follows LIFO policy. Okay, last in, first out. So stack means what? You can think of it as maybe a stack of books. Okay, a stack of books. So the first book that you put in the stack is the bottom one, right? Then on top of that, you stack more books.
Yes.
So which book can you withdraw first? The book that you inserted last, that is on the top, right?
Yes.
So if you want to take one book out, the first book that you have to take out is the one that is on top. So the last book that you inserted is the first one that can be drawn out. So last in, first out, LIFO. Okay. So stack follows LIFO policy. Now, what are the functions that we can perform in stack? So you can insert elements, you can delete elements. Okay, these are called, if you want to insert some element in stack, then the operation is called push. Okay, so there is a push function which can insert an element. Now, how is an element inserted? See, if this is a stack, okay, let's say this is a stack of disks. So this is the bottom one. So this is the first element that you inserted, right? And the top one is the last element. So the last element is always called top. Okay. Top is a variable that always contains the last element. Now when you use this push function, so this is used to push some new data onto the stack, some new element onto the stack. So this will always push the element on top. Here it will add the new element. Okay, not at the bottom. Just similarly, just like how you stack books or plates or anything. Now another, for delete, there is another function. It is called pop. Okay. So if I want to delete one node or one element, which one can I delete first?
The top element.
Top element, right? So whenever you write some stack, let's say S is some stack, so S dot pop, this function will delete the top element. Okay, automatically it will delete the top element because pop means the first top element is deleted. Now for queue, it is mostly just the opposite of stack. So queue means what? What do you know in English language? Queue means a line, right? So I say that there is a queue at the ticket line. There is a queue at the ticket counter. That means that there is a line of people, right? So similar concept. See, in a normal queue, what happens? Who is the first person who gets the ticket? Who stands first in line?
Yeah.
Yes.
Right. So first in, first out. This is the policy, FIFO. Okay. Queue follows FIFO policy. The person, like if this is a queue, these are all elements standing one after another. Okay. This is the first element. So he will be out first. This is first in, first out. This was inserted second, this was inserted third, this was inserted last. Okay. In case of queue also, there are operations like push and pop. Instead, they are called, when you want to insert some element, it is called enqueue operation. Okay, and when you want to delete, it is called dequeue. These things weren't discussed in week 8, second session. Don't know, they should have been. Anyway, okay. So when you want to insert a new element, where is it inserted? At the beginning of the queue or at the end of the queue?
End of the
End of the queue, just in like real life scenario. More people join the end of the line. So end of queue will be NQ. Okay. And where can I delete from? Delete means what?
From the beginning.
You want to, right. So whenever you want to delete an element, you have to start from the beginning, right? So sometimes, let's say there is a queue that has these 4 elements. Now I want to delete the third element. So what can I do? I don't want to delete the first 2. I want the third one to be deleted. So the way you can do this is you have to take a separate array. Okay. So first you have to do dequeue operation on the first 2 elements, this one and this one, because this is the only way that I can delete elements from the front. But I won't delete them. I will take them and I will store them elsewhere. Okay. And then I will delete this third element. And then I can again insert them. The order will become different. If you want to keep the order same, then you can also put this element in that same array and then again put them in this queue in the same order. So basically, wherever you want to delete the element, you have to start from the front of the queue. Okay. And anyways, all of these things are not required in DBMS. Okay, I'm just telling you what is stack, what is queue.
Ma'am, from the perspective of flexible,
Hmm.
so it will have a predefined number, right? I mean, it can accommodate or
No, it can accommodate any number. Like it can grow or shrink. Okay.
okay,
The memory will be allocated like that.
okay.
Queue, stack, linked list. Linked list. These are all flexible in size. So there is one question. So stack and queue, basic idea you got, right?
Yes.
These
Yes,
are just
Yes,
data
ma'am.
structures. Okay, just linear data structures, nothing else. So let's do this one. Consider the following elements added to a data structure Y in the order this. So this is the order in which elements are inserted. Look, this is the stack queue question only. So identify the correct statements. If Y is the stack, that means Y is the stack in which these elements have been inserted. Then the top of Y will be 25 or not. Top
Yes,
means
it will be.
last element,
yes.
right? So this 25 will be inserted last in the stack, so top will be 25. So this is correct. If Y is a queue in which these elements are inserted, then element to be deleted first is 25. Is that correct?
No, false.
So what
No,
is the
ma'am.
element deleted first?
120.
120.
First in, first out. So this is wrong.
Ma'am, if we want to add, we will add at last.
In case of queue, yes, we'll add at last.
Yes.
Okay. If Y is an array, then time to search 5 would be linear time or not? Linear time means, what does
No,
linear
ma'am,
time
it would
mean?
be constant.
Will it be constant time? Think.
No. Yeah, linear time.
Order
Linear
of
time
n.
means order of n, right?
Yes.
So if it is an unordered array, that means the elements are not sorted or anything. That means I have no other way of finding, right? I have to traverse the whole thing. So order of n
Yeah.
time is needed to search any element. So C is also correct. If Y is a binary search tree, then what is the number of comparisons to search 90? Will it be 7 or not? So let's quickly draw the tree once. Without drawing the tree also you can solve, but I'm not going to do that because that will mess with you. So let's not get confused. So 120 is the root, 56 left subtree, 78 right subtree, 109.
Ma'am, 78.
78 is left subtree also, correct. So 78 will be right of 56 here. 109 will be again left subtree.
Right of
Right of
78.
78 here. Then 5,
Left of 56.
100,
Left of 109.
80.
Left of 100.
So 80 is less than 120, greater than 56, greater than 78, less than 109, less than 100. So here 76.
Left
Left of
left
78.
of 78.
23,
Right of 5.
Right of 5.
90,
Right of 80.
Right.
yes, right of 80. Then 256,
Right of 120.
20.
16,
Left of 23.
Left of
Left
23.
of 23.
and 25.
Right of 20.
Right of 20.
Okay. So now they are saying that if I want to find 90, how many comparisons I need? So I have to start with the root. So this is first. Then 90 means I'll go to left subtree. So again 56 is the second comparison. Then it is greater than 56, so right subtree. Third comparison with 78. It is greater than 78, so right subtree again. Fourth comparison with 109. Less than 109, so left subtree. Fifth comparison with 100. Then again left subtree.
Comparison with 80.
Then last comparison with this node, which is the correct node. So how many total comparisons? 7.
7.
So this is correct. This question is clear for everyone?
Yes.
Yes.
No, ma'am. Can you take again and how to approach
Come again.
this?
Your voice got cut off. Repeat.
Ma'am, first thing, how to check
Uh,
stack
ma'am?
and queue.
Can others hear him? I cannot hear him.
Ma'am, he is asking about option 2. How to check that queue and stack out.
See, stack and queue, just
Yeah.
remember this much, that stack follows last in, first out, and queue follows first in, first out. So in case of stack, what is the last element? That is, will always be on top of the stack. Okay, so top will always contain last element. And in case of queue, the first element will be the first one that we can delete. So first in, first out. Okay, so for stack and queue, just remembering these two simple things is enough. LIFO and FIFO it follows, and in case of stack, the deletion or insertion happens on the top, and in case of queue, the insertion will happen after the last element, and deletion, only pop is the operation for stack. So deletion will also delete the last element in stack. But in case of deletion, in queue, the first element will be deleted first. Right? That is enough. Okay, nothing else.
Ma'am?
Can you ma'am, compare it? And, well, how to count there?
How to count what?
Comparison.
Is my internet bad or I cannot
No, ma'am.
hear
His
him?
voice is not audible.
Comparison.
Comparison between what? Stack and queue.
No, ma'am. They are asking for how we count the comparison.
Ma'am, after option 4,
Are we
he must-
done?
yeah, option 4 about the
Oh,
option.
that you just have to start from. See, first just create the tree, then just start from the root and see how many comparisons it takes to reach the desired node. Comparison means every time you check a node to see if that is the desired node or not. That is one comparison.
Ma'am, root included, right?
Yeah, the last one included.
No,
The
root.
desired, yeah, root always included. Yes, that is the first one.
And the last one is the one required.
Yes. So anyway, to find that that is the one required, then also you have to compare, right? So that one is also included. So both root and last one included.
Ma'am, in option number D, if the question doesn't ask for BST, then also we can do by this process.
No. If it doesn't ask for BST, then you don't know what data structure it is. So you don't know how many types of comparison. The data structure has to be mentioned. Otherwise, you have no idea what to compare.
Ma'am, how to do it without drawing this BST? You said no, we can do. without
Yeah, see, just look at the pattern. Okay, if you want to do it without drawing, then just look at this. So you know that the first node to be inserted will be 120. Basically, you are doing the tree only. You are inserting them in the tree only in your head. Okay, instead of drawing, just think of it. Like, okay, first comparison will be with 120 because it's the root. Then I know that 56 will come to the left because it is less than the root, and 90 is also less than the root that we are trying to find. So I have to compare with 56 next. then you know that 78 will also be in the left side of the root because it is less than the root, but it is greater than 56, so it will be on the right hand side of 56. And I also know that 90 is greater than 56, so that will also be on the right hand side. So next comparison will be with 78. Like this you have to go. So other instead of doing all of this, it is better to just draw the tree. Okay.
Okay.
Anyway, you have to think like this only. So this is a very good question. Okay, so all of the types of your data structures are discussed. Okay, this one. Okay, do you know what are number of cylinders?
Yeah, ma'am. Number of tracks per surface.
Number of tracks is number of cylinders, correct. So this is asking that consider a disk having 16 platters, 2 surfaces per platter, 16 tracks per surface, 2048 sectors per track, and 512 bytes per sector. So let A denote minimum number of bits required to access a sector. So let's first find A. Okay, minimum number of bits. So first for that, what do we need? Total number of sectors we need.
Total number of sectors.
So that will be what? Total
16
number of
into 2.
sectors.
Into 2 into 16 into
16 into 2 into 16 into 2048 into no, just that.
Only till
Till
2048.
2048, yes. So this is how much? 2 power 4 into 2 power 1 into 2 power 4 into 2 power 11. So this is 2 power 20. Right? So minimum number of bits required is what?
20.
20.
Yeah.
So definitely I can eliminate option B from here. This is not correct because 16 it's not going to be. Now B denotes the number of cylinders required in the disk. So this how will I
16.
find? Number of tracks per surface. So 16
Yeah.
will be the answer. So definitely I can again eliminate option A. So among these two it will be. Now C is denoting storage capacity. Storage capacity is number of sectors into size of one sector. So total number of sectors is 2 power 20. Size of one sector is 512 bytes per sector. So what is the total capacity? 2 power 20 into
2 to the power 9.
9. So 2 power 29. That means 2 power 9 megabytes I can write. 2 power 20 is
Yes.
megabyte, right?
Yes, ma'am.
Yeah.
So 512 megabytes.
512
This is
megabytes.
so option D.
Ma'am, could you please repeat storage capacity?
Storage is what? Number of sectors into size of one sector. So number of sectors we already found 2 power 20, right? And size of one sector is given 512 bytes per sector. So 512 I can write as 2 power 9, right? So 2 power 20 into 2 power 9 is 2 power 29. That many bytes. So again I know that 2 power 20 bytes means 1 megabyte. So 2 power 9 megabytes means 512 megabytes. That is the storage capacity. Clear?
Okay, ma'am.
Okay. So this type of question you know will come at least one.
Ma'am, and yeah, 2
Yeah.
power 10 is 1 KB, right? 2 power 10 is 1.
Yeah, 2 power 10 bytes is 1 KB and 2 power 30 is 1 GB.
Okay.
Okay. Also remember these ones. What was it? 10 to the power minus 3 second means 1 millisecond. Minus 6 is 1 microsecond. Minus 9 is 1 nanosecond. Oh, I forgot to give you that formula chart, no? Oh, yes, someone also
Yes, ma'am.
reminded. Okay, today I will post it. Today I'll post. Okay, so
Ma'am,
see
where
this
will you
one.
post that chart?
Ma'am,
On Discourse. Yeah,
Okay.
someone also
Please-
reminded me. I forgot it totally.
Can you show the previous slide for a second, please? Thank you, ma'am.
See this one. So statement 1 is saying there are n nodes in a binary tree. So maximum height of binary tree is n minus 1. Is this correct?
Yeah.
Ma'am.
So when will this happen?
When the binary tree is skewed
Skewed.
to
Correct.
the right or
That
left.
means it is sorted, right? All the nodes are inserted in a sorted order, either incrementing or decrementing, whatever. So it can be left skewed tree or right skewed tree. So maximum height will be n minus 1. So statement 1 is correct. Statement 2 is saying if a binary tree has height h, maximum number of nodes in the tree will be 2 power h plus 1. Is this correct?
No, ma'am.
So what is maximum number of
2 to
nodes?
the power h.
2 power h plus 1 minus
Minus
1.
1.
Minus
This
1.
is the formula, right? So this is wrong. So option D. Statement 1 is correct, 2 is wrong. Okay, this is again an LRU question. So this is asking, see, number of misses minus number of hits. So this is the block reference order given. Let's quickly solve this. So how many slots are there in the buffer? 4 slots. So we know that the first 4 are what? 4, 6, 4, 1. In this also we can see one hit, that is 4. Right?
Yeah.
So if I don't draw the buffer, will you be able to keep up if I do it here? Let's
Yeah, ma'am.
check.
Yes,
Okay.
ma'am.
So first if I insert 4, this will be a hit or a miss?
Miss.
This will be a miss. 6 will be again miss.
Hit. Miss.
This 4 will be hit or miss?
Hit.
Yeah, hit.
This will be a hit. So at this point, what is the least recently used block?
6.
6. That means it is in this order, right? 4 on top, then 6. Then 1. This is hit or miss?
Miss.
Miss.
Miss. This 3 is hit or miss?
Miss.
So now currently up to this point, the buffer looks like this.
3, 1, 4, 6. Yes.
Correct. Now 2 is hit or miss?
Miss.
Again 4 is
Hit.
Hit.
okay. Let's write this order down. If 2 is a miss, okay, that means it will be like this now. Okay.
Yeah.
Then 4 is a hit, right?
Yes.
So 4 will come on top. 2, 3, 1. Then 1 is also a hit.
Hit.
Yeah.
It will be 1, 4, 2, 3. Then 4 is again hit.
Hit.
So it will be 4, 1, 2, 3.
4.
2 is again hit. So it will be 2, 4, 1,
2,
3.
4, 1, 3.
So total number of miss, how many did we get?
5.
5. Total number of hit, also 5. So 5 minus 5 is 0. Okay, so instead of writing all these buffers, you can solve it like this also once you're comfortable. Okay, this is clear for everyone?
Yes, ma'am.
Yes, ma'am. Could you show previous slide once? Yeah. Okay, ma'am. Thank you, ma'am.
Excuse me, ma'am.
Yeah.
Ma'am, can you please take some questions regarding canonical covers or something like that? Will you consider
Piyush
that?
sir told me that 5 and 6 have been discussed, so he
Yes,
told me to do 7 and 8 only today. Okay, I don't have questions prepared from that right now. Okay, let me check. Okay, if I can get one or two, I'll solve it.
Okay, ma'am. Thank you.
But canonical cover questions were taken in last class, right?
Yes, ma'am.
Yeah, ma'am.
Yes, ma'am.
Okay, so
Yes.
even if I can't find one right now, because I didn't prepare from 5 and 6 weeks, so I will post one or two questions with solution, okay, on discourse. How to find canonical cover. I'll
Yes,
try
ma'am.
to find one, but if not possible, then I'll post it.
Yes, but if you can please at least tell us that how to solve them quickly in
Yeah. See,
and solve some-
canonical cover, there are rules are already given to you, right? Canonical
Yes.
cover,
Yeah,
okay,
ma'am.
tell me this. First, if functional dependency set is given to you,
Yes.
what are the steps to finding canonical cover? Canonical cover is what? Minimal cover, right? That is
Yes.
minimal set of functional dependencies that will do the same work.
Yes, yes.
So
Yes.
for that, what do? We have to remove extraneous attributes.
Yes, attributes, yes.
Right, and we have to make sure that on the right hand side of each dependency there is only one attribute present.
Yes. Yes.
Okay, so these are the two main things. Again, if there are any transitive dependencies,
Yeah.
right, then we
Yeah.
will remove the extra dependencies. Only
Yes.
these few steps. Okay, so you can go one by one with these steps. Let me see if I can get a functional dependency set. I'll solve one problem.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
See, consider a binary search tree consisting of 15 elements. So m be the maximum height possible for a given binary search tree, and n be the minimum height possible. So what will be the value of m minus n? So 15 elements. What will be maximum height? Everyone knows.
14.
14.
Minimum height, to find that you have to draw a full binary tree. Okay, that means we are going to fill up the tree till we hit 15. So let's draw that. So this is the root. Okay, root can have at most how many children?
2.
Two.
So 3 elements we got. Okay, 1, 2, 3. Now in the next level, so this is level 0. This is level 1. Next level, how many children possible? 4.
4.
So these are what? Nodes 4, 5, 6, 7. This is level 2. Next level,
3 level.
always start, I'm starting from the left. Okay.
8 more.
So we have 15 elements. So 8, 9 here. 10, 11, 12, 13, and 14, 15. This is level 3. So for a tree of height 3, if it is a full complete tree, then it is possible to have 15 nodes.
Yeah.
Right. So for 15 nodes, minimum height is what? Level 3.
3.
So m minus n will be 14 minus 3. That is 11. Understood this question?
Yeah, ma'am.
Ma'am, what is 14?
14 is what? Maximum height. Maximum height is n minus 1. So if there are 15 elements, so 15 minus 1.
Okay, ma'am. Thank you.
Okay.
Ma'am,
See how-
first level will be 0 or 1?
0. Root level is 0. Then 1, then 2, then 3. Okay. So see, this type of question, if you know how to solve it, it hardly takes 30 seconds to solve this question. And there are 3 marks.
Ma'am.
Okay. So always,
Ma'am,
yeah.
if number of element is high, then how to find minimum height? Let's
No,
suppose
we
40 to 50 number of element.
right. Then you have to know that, okay, in one level, how many elements are increasing? So it is increasing in a logarithmic way, right? So first level 2, then 2. So there are 2 elements in level. First level, level 0 is 1 element. Then level 1, there are 2 elements. So if there are 2 elements, then level 2 can have at max how many? Each element having 2. So 2 into 2, 4.
Yeah.
So level 2 has 4 elements. Level 3 can have at max how many? 4 into 2, 8. So just the double. Okay. So you
Okay, ma'am.
can go like this, that how many levels it will take to take 40, 50 elements. It will, for 40, it will take how many? Just one more level. I think, wait, 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 2 is 16, but there are again other elements on top levels. So 15 plus 16, okay, it will take up to level 5 to get 40 elements. Okay. So whenever you're doing that double thing, don't forget that there are already elements in root level 0, level 1, level 2 like this. So it is just power of 2, the log base 2. Anyway, we won't give you that big of a number, obviously, but still.
Excuse me, ma'am. Ma'am, can we do it like this? 2 to the power h plus 1 minus 1 is equal to 15 and then find h. That will be
2 to the power h plus 1 minus 1 is the formula for what? See, it is the formula for maximum number of nodes.
Yes.
Right. So you
Yeah,
need
ma'am,
the
that
height
formula
here.
will work.
So this formula, if you put it like this, 2 to the power h plus 1 minus 1, and I have total nodes, maximum number of nodes are
15.
like 40 or whatever. He asked like 40, 50, so let's take 40.
Yeah.
Why this is going to be a little difficult to see? Because now I have to bring this to a power of 2 to solve this.
Yes. Okay.
Okay. So instead of doing that, I would say that if you calculate it like this, it will be easier. Because not always you will get elements in power of 2, right? If this was, let's say, 64, then in that case you can write like this. So h plus 1 equals to 6, h equal to 5. Okay. That is easy, but not always you will get in 2's power. Okay. See this one. Consider a magnetic disk with 4 platters, 2 surfaces per platter, 1024 tracks per surface, 2048 sectors per track. Disk capacity is 8 GB. So what is capacity of one sector? So basically disk capacity is given to us. So disk capacity is equal to number of sectors into size of one sector. This is the formula. So if this is given to me 8 GB, number of sectors is how many? 4 into 2 into 1024 into 2048, right?
Yes,
And this, let's call it S. This is what I have to find. So 8 GB means in converted to bytes, how many it will be? 2 to the power 33,
Yeah.
right? And this is what? 2 square into 2 into 2 to the power 10 into 2 to the power 11 into S. So S will be 2 power
2 to the power 9.
33 by, there is
2 power
21, 24. So 2 power 9. 2 power
1024
9 means,
bytes.
no, 2 power 9 is
512.
512. 2 power 10 is 1024. Okay. So 512 bytes per sector. This type of question you are pretty familiar with now. We have done a lot of this.
Ma'am, in which unit you convert GB?
Sorry? GB.
Yes,
1
ma'am.
GB means what? 1 GB means 2 power 30 bytes.
Yeah.
Right? And 8 is 2 power 3. So 2 power 33 in total. I just converted into bytes. That's all.
Okay, ma'am.
Okay, see this. Construct a binary search tree inserting the following elements in given order. Find out elements present in leaf nodes. Okay. So leaf nodes, you have to construct the tree. First is 30. Okay, quickly tell me. 20 is left of 30. 27 is where?
Right of
Left
20.
of 30, right of 30.
86.
Right
Right
of
of 30.
103.
Right
Right
of
of 50.
25.
Left of 20.
Then 60.
Right of left of 80.
Left of 80.
90.
Left.
Left of
Left of
103.
103.
10.
Left of 20.
15.
Right
Right
of
of
10.
10.
Right of 10.
Okay. What are the leaf nodes?
10,
15 is a leaf.
25, 60, 90.
25, 9.
10 is not a leaf. 10 has a child. 15 is a
15.
leaf.
15,
25 is a leaf.
60, 90.
60. 90.
90.
Leaf is those nodes which don't have any children, right? So 15, 25, 60, 90. So which option? Option A. Now here the tree is given to you. Okay. Which of the following is or are correct
Ma'am, can you show
insertion
the
order?
previous question? Okay, ma'am.
Okay. Okay, here the tree is given to you. It is saying which of the following is or are correct insertion order that will result in the given BST. So this is a little time consuming, okay, because you have to check all 4 options.
Yeah.
So which of them are correct insertion orders? So let's check with the first option. 46 is root, fine. Then 71 comes left subtree, fine. 21, I'm sorry, 71 right subtree, 21 left subtree, fine. 11 should be left of 21,
Yeah.
okay. 35 should be right of 21, fine. 26 should be left of 35, fine. 16 is less than 21 but greater than 11, so right of 11. 16, 82, 93. Okay, let me check once. 82 is 93. 59 here. 65 is greater than 59. 41 is greater than 35. So option A will be correct.
Yeah.
Okay. But see, when the wrong options come, it is easier to eliminate. Why? Because 46 is root, 71 right, 21 left subtree, 11 left of 21. But then it is saying 26. Now, if I insert 26 at this point, after I've inserted these 4 nodes, okay, these 4 have been inserted. Then 24 should come, 26 after this, if I insert, where should it come? Right subtree of 21. So here that there should be 26, right? But that's not the case, so this is wrong. Similarly, here also check where the order is getting different. So 46, 21, 71 is still same. Okay, because 21 will be in left subtree and 71 will be in right subtree. Then if I bring 35, that will also keep
Yeah,
it
it
correct.
goes at right position.
Right, that is also correct. 35 will be in correct position. 11 is also in correct position. Then if you bring 26, that will also be correct.
Correct position. Yeah.
Okay, so this entire one is correct. Even though it is a different order from A, this entire order is correct. It will also give you the same tree. But this one is
Yeah.
wrong. Why this is wrong? Where am I getting it wrong? See, after
Ma'am,
I
the last
insert 11, then I insert 16, it is fine. Then 26. So
Fine.
26 is also
is
fine.
also fine, ma'am.
Then 82. Okay, let me
Yeah,
quickly
it would
draw
go
this
fine.
one.
At 65 and 59, it falters.
65 and 59. Okay, let me check one quickly.
Yeah, earlier this is 59 and then 65. Here it's 65 and then 59.
This question will take a little bit of time. Nothing you can do. 16 will come here. 26 will be here. Then 82 is here. 93 is here. 41 here. Then 65 will be left. Okay. So instead of 59 coming, 65 will come here. So this is wrong. So this type of question you have to check all four options, right? Now this is again a buffer one. Let's see what it is asking. How many misses will occur? This I'm not solving, okay, because we have already solved this type of question a lot of times. So you can solve this on your own.
Yes.
Okay, let's quickly do this, but I won't draw the buffer. Okay, let's just do it from here. So 3 slots in this buffer. Okay, not 4. 3 slots. So first is obviously a miss.
Miss.
5 is also a miss. 2 is also a miss. Right. So what does the buffer look like now? 2, 5, 4.
Yeah.
Then if 5 again comes, this is a hit. It
Yeah.
is 5, 2, 4.
5 to 4.
3 is a miss. So it is 3, 5, 2. 4 is also a miss. So it is
Yeah.
4, 3, 5. 2 is also a miss. This is
2,
2,
4,
4,
3.
3. 5 is also a miss.
Miss.
5, 2, 4.
5 to 4.
3 is also a miss. 3, 5, 2.
3, 5, 2.
And this last 4 is also a miss. So 4, 3, 5.
Yeah.
Right. So how many misses? Except for one, all are miss. So
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 misses.
Hello, ma'am. I have a doubt in this one. What if the hit was in the last buffer? I mean,
Then the last, you mean the last slot, right?
swap, we will swap only with the last one or in the middle one, ma'am?
Wait, I don't understand. Like the element which you hit is present in the last slot, you are saying?
Yeah. For example, the 3, 5, 2 is there, right? I mean,
Right.
that
Now,
hit.
if let's say after this, if you reference block 2, so that will be a hit, but it is in the end, right?
Correct. Yeah,
So
you are right.
after this 2 should come on top. Rest of the order will remain same, so it will become 2, 3, 5.
Okay. 3, 5. Okay, ma'am.
Yeah,
Thank
this
you.
order will not change. Only the reference block will come to the top. Okay. Okay, this question is also same. So fine, let's solve it if it is there. 24 is root. 60 is to the right. 48 is?
Left of 60.
12 is?
Left of 24.
72?
Right of 60.
96?
Right of 72.
36?
Left of 48.
108?
Right of 96.
And 84?
Left of 96.
So let's take node 60, this node. Left subtree contains how many nodes?
2.
Right?
4.
So x minus 1 absolute value will be what? 2?
2.
So 2 is answer. See, these questions have repeated over the years. Okay, so they are important. These are all PYQ questions only. Okay, this is asking what is the height of the resulting binary search tree. So even though this looks like an easy question, a lot of people will get this wrong. Why? Because they start with level 1. Okay, so let's insert these 27, then 23, 33 here. Then we have 49, 51, 92. 83 will come where?
Left of 92.
Left of 92. 10?
Left of
Here.
23.
And 78?
Left of
Left of 83.
Left of 83. So what is the height? Longest path from root to leaf. So if this is level 0, this is level 1, 2, 3, 4, 5, 6. So height is 6. Don't start from 1. Then you will get height 7. Okay. Base root level is always level 0. So 6 is the answer. A lot of people got this question wrong. They wrote 7. Okay.
Here
7
the
is,
minimum height and maximum height will be
so again, see what is the maximum height here? In this tree. Okay. Maximum height possible is what? How many nodes are there? 9 nodes are there. So maximum height possible is 8.
9. Yeah, 8.
Okay. And minimum height possible, if you want to do this, then minimum height, the nodes you have to arrange in that order, like I did. So
2.
minimum will be, we have 9, right?
3.
So level 0, level 1. So this is still giving me 7 only. So level 3. 3 is minimum. Okay. This is max, this is minimum. Okay.
okay.
Although this will not happen, because if I insert in this order, then this structure we will not get. If you change the order, then you can get this structure. Okay, so these are all the questions I wanted to discuss. Now let's take one of your canonical cover questions, right? Okay, give me 1 second. Let me find an example. I don't have it ready. So do you have any doubts from week 7 and 8? Sorry.
Ma'am, I have a
Numerical on what?
I have a doubt in this question. We found the height of the resulting binary search tree is 6, correct?
6.
And the number of elements is 9. Total
9.
number of elements is 9. Why you have put x is equal to 8?
So I'm
9
saying that if I wanted to say what can be the maximum height of a tree having 9 elements, so that will be 9 minus 1, 8.
Okay, that's fine.
Okay, and in case of that same 9 element tree, what is the minimum height is 3 if we insert elements like this.
Yeah.
Okay. So if there were like 15 element, the maximum height will be 14.
Right. Yes. N elements, maximum height is n minus 1.
N minus 1. Okay.
Yeah, what numerical?
Ma'am, can I share one question on canonical covers?
Yes, sure.
Ma'am, I'm pasting it in the chat box.
Okay. This is redirecting me to some exam.
Yes, ma'am. It's a kind of a portal where we have all the questions. Question number 4 from there.
Okay. Wait.
Ma'am, you can use practice mode in left side. There is a practice mode.
I'll just take a screenshot of this and solve. Okay.
Hello, ma'am.
Yeah.
Please discuss some question on week 5 and 6.
Week 5 and 6, the problem is that Piyush sir told me yesterday to just discuss 7 and 8. So I did not prepare any questions from 5 and 6 because he said that he had taken enough questions.
Okay, ma'am. Then just discuss some key points.
Yeah, that I can do. I can tell you what
Okay,
are the
okay, ma'am.
important two.
That will be.
Ma'am, can you take question number 9 from mock?
Session is over.
7, 8, I have nothing new to discuss now. If you have doubts, I will take those. Okay.
Yes, ma'am. Please take the question number 9 from mock after this one.
Okay. So this is visible to you? Question?
Yeah, ma'am.
This
Yes,
is the one, right?
Yes, ma'am. It is not exactly the canonical one, but the equivalent they are asking. I just want to know what is the quick way to solve this.
Yeah, just 1 second. What is this? This portal that you send me, where do you get this?
What, ma'am?
Like this is provided to you, this quiz practice space.
Yes, I get this from an group.
Okay, okay.
Like eighth grade, this is another tool for the students, ma'am. It is available.
Alright,
in all
alright.
subjects.
Okay.
It is downloaded by some student only.
Oh, that's why. Yeah, I haven't seen
It is, ma'am. This website is also mentioned in our discourse.
Okay. No, this is good. Okay. All right, let's solve this. So this is saying that which of the following functional dependency sets is equivalent to the given set, right? So equivalence, how do we check for equivalence? So if I say that I want to know if F1 set of functional dependencies is equivalent to F2. So I have to check whether all the dependencies in F1 can be derived using dependencies in F2, right? Also, I have to check if F2 dependencies can be derived by those in F1. If both of these satisfy, then I can say F1 is equivalent to F2. This is the
Can you
concept,
repeat?
right?
Yes,
Ma'am, that was covered.
Yes, ma'am. It is covered in previous class.
This question.
Yes, ma'am. Piyush sir is taken this question.
Yeah, that's what I'm saying, that these Piyush sir told me explicitly that all of these
Question was
topics have been
discussed.
covered.
Ma'am,
No,
there
ma'am.
was some
This question is
confusion
not
last
covered.
time.
Another question is
Yeah.
covered, but not this one.
Yes,
I
there
have
was some
watched this
confusion.
Okay, okay, no problem. See, let's just solve it. Okay, since I have taken it, let's just solve it. And someone has an issue. Okay, so this is our given set. Okay, now to solve this question, let's break down this set. Okay, because you can see in the options, none of the functional dependency sets have. What is the difference you can tell? That none of the functional dependency sets have a single dependency where there are more than one attributes on the right hand side. That means these are all simplified.
Yeah.
Yes,
Right?
yes.
So let's simplify our set first. Okay. This F. So J determines K is fine. JK determines L. M determines LJ. Instead of this, I can write M determines L, M determines J. This is fine?
Yes, ma'am.
Yes.
Again, Mn determines J and Mn determines K. This is also fine.
Yes, ma'am.
Now let's say what else can I get rid of? Okay. So,
Mn determines J.
So M determines J. Then anything I add to M will just be an extraneous attribute, right? Anything I
Yeah.
add to M will be extraneous. So
Yes,
I can
ma'am.
remove this one. This is not needed.
Yes.
Now tell me one thing. If M determines J and J determines K, then Mn determines K can come from there.
Yeah, ma'am.
Yes,
So
yes.
this do I need?
No.
No. Right. Now J determines K, JK determines L, M determines L, and M determines J. So nothing else I can remove from here, right? These are all independent. So this is
Ma'am,
my.
excuse
Yeah.
me, ma'am. How do you remove N determines K?
Because M itself determines J, right? And J can
Yes.
determine K.
Okay.
So from
Okay.
these two, I can get this one, where
Right.
N is just extraneous.
Okay, ma'am. Got it.
So this is the smallest set I can get till now. Okay, now what are the options? See. So let's start with the bottom one. J determines K, J determines L. Okay, let me write my set here. So this is the set we have now. J determines K, JK determines L. Then M determines L and M determines J. Okay, so I'm starting with this option. So J determines K, J determines K, fine, matches. J determines L, okay, and JK determines L. So are these two same?
If J is determining L, then adding anything to J
Right, but
determines L.
in our
No,
set,
no, then it's not correct because JK we are not deriving anything else. JK is as a whole is deriving L, but we can't derive
so
anything.
I don't know that L is not directly dependent on J or K, right?
Yes, yes.
It together it can determine L, and
Yes,
here it
ma'am.
is
And
saying
but
J.
J itself determines K, so JK obviously, so J
Yes,
obviously
I
alone
was
can
coming to
determine.
that only, right? You're correct. So J determines K and JK determines L. So this K is coming from J only, no?
Yes, ma'am.
So instead of
K
writing
is
this, I can also
extraneous.
write
Yes, ma'am.
I can
J
also write
determines.
J determines L.
Yes.
K is extraneous. Good. See, now you have learned this. This is good. So out of these two, I have now found two matches, right? Now M determines J is also present. Mn determines K. Okay. So Mn determines K. How can I get this? So M determines J and J determines
J
K.
determines K.
So M can determine K.
Yes, yes.
Now with M, anything I can add that can also determine K.
Yes.
Ma'am,
Yes,
So,
ma'am.
so this is correct. So can I say that this set and this set are equivalent?
Yes, we can say that. Yes, ma'am.
So this is the
Yes.
answer. Okay. This is an MCQ, I think. So only one answer will be there.
Yes.
ma'am,
Thank you, ma'am.
I'm determined and also we can try now. That is
Sorry,
also extra FD inside.
I cannot hear you. Come again.
Ma'am, I'm determined L is also extra FD now.
Which one is extraneous? M determines?
L.
M determines L. See, J determines K. And J determines K, JK determines L. So from that we got J determines L. So M determines J. So from there we can get M determines L, right? So I don't even need this one. This is also not needed. So our set, if I just have this is the same as the original set. Understood? This wet. If I have this, from this, I can get the original set. What
Yeah,
she
this is
said
the
is,
minimal set.
this is the minimal
Ma'am,
set. Okay.
one more FD is there now.
One more?
I'm undetermined K.
Wait. I don't think we can make this any less. I think this is the minimal set. Because
Yeah, this
see,
is minimal.
M determines J. Okay. J determines K, J determines L. None of these can be derived from anything else. What she said is this last one we removed. Okay. This M determines L. Why we remove this? Because M determines J, J determines L. So from these two, by transitive dependency, I can get M determines L. So this is the minimal cover. Okay. This question is clear?
Yes,
Yeah,
ma'am.
ma'am. Ma'am, can we do this by checking the cover? I mean that.
Yeah, like you can find the minimal cover for both. Okay. But that will be more time consuming actually because see,
No, I
this
mean
one.
like we check for suppose we have two FDs. If X covers Y and Y covers X, then we
Right,
say
right.
X and
Yes.
Y are
Then
equivalent.
X and Y are equivalent. That is the correct way.
So that will also work, right?
Yes. This I did to save some time. Okay.
Okay, ma'am.
Because you can see that this might be it because these two are very similar options.
Yeah, ma'am.
Okay. Obviously, yeah, for you who are doing this the first time, you can do that way, that x covers y covers x, then x and y are equivalent. Okay, what other question? Question
Ma'am,
9
in
sounds.
this question, we have to match the dependency given with the dependency need to take out, right?
Not match exactly. Okay, I'm saying that both of these are doing the same work. If both dependencies are deriving the exact same set of attributes, I mean, both of them can derive each other. That means this one, like, 1 second. So in this example, I first did the comparison between this set and this set, right? So you again now do this comparison. So I now found the minimal cover, right? So now I want to check if this F1 set of functional dependencies covers F, and if F covers this F1. Okay. So this is the right way of checking. So check if F1 covers F. So J determines K is present, fine. J determines L is also present, fine. M determines J is also present. Now Mn determines K. Okay, this one can be derived from where? M determines J, J determines K. That means M alone can determine K from these two. So N is just an extraneous attribute. So this is basically M determines K.
Ma'am,
Right.
C could be an option to us, right? Could be correct as well.
Okay, let me check. And again, this M determines K I can get from here. M determines J, J determines K. So these two are
Yes.
equivalent. Okay. Now he's saying that this one might be true also. So J determines K, J determines L, M determines K. Mn determines K. But what happened to M determines J? That is not present anywhere. Right? M has to determine J also in order for it to be equivalent. That is
Ma'am,
not happening here.
ma'am, I had this doubt. Does Mn determines K? Can we not say that M in the main set it is Mn determines J and J determines K? So Mn determines K. That is also valid.
See, M alone can determine K. N is extraneous. N is
So
not
in
even needed.
so in that case, that N should not be there, right? That's not a right option, right?
No, since this is they haven't mentioned anywhere that this is a canonical cover. This is not minimal.
Okay.
This is just a cover. This is just a set. So it
Okay. In
can
the
be present.
question, yeah, in the question, if it had been given it following other canonical covers, then it would
Yeah.
have been a
Then
wrong.
it won't be there. Right. Then it would be wrong.
Okay.
Okay, but these two are not equivalent. Why? This one and F1 are not equivalent because M determines J is not present in this set. And you cannot derive it also. Can you see J on the right hand side of any of the dependencies?
Ma'am, that's
No,
what
ma'am.
I'm asking. That we have to compare with the main set given, right?
Yeah. Here you are going to compare with this set and the minimal set that you derive from the main set. Okay, this is the minimum set I derived from the main set of dependencies given. Now with this, you are going to check equivalence of all these four. Okay. No need to find the minimal set for all these four also. Just find minimal set for the dependency set given to you. Okay, and then compare with all four. Question 9 is
Okay.
which one?
One more thing, ma'am.
Ma'am, from Oak.
Okay. Yeah.
Ma'am, one more thing.
Hmm.
Like sometimes they are doing something with the like R1 given, R2 given, that we are taking out the closure. This thing and that thing is same, right?
Yeah. See, closure means what? Closure of attributes, you're saying?
No, you're not getting my point. I'm not able to explain you the correct question. That one, this one is dependency, functional dependency, right? Then we have functional lossless dependency and all that. Okay. Then for that one, like we are joining the R1 to R2, like that we are joining the series to get the same functional dependency.
Can you give me an example? It's not clear to me.
Like when we are joining R1 is given, R2 is given, the main functional
R1 and
dependency
R2 are
is
two different relations, right? And you're saying that you are joining R1
no,
with
they are
R2.
part of it because R2 is driving from R1, like that questions are there. R2 is getting derived from R1 because some attribute is common.
Okay, yeah, fine then.
Okay, that one also function dependency, the same thing only, right? This one and that one.
What are you trying to check in that question? Like, what is the question asking?
Ma'am, it's asking for the checking the function dependency.
Yeah, see, if you want to check, like you want to say that functional dependency sets for R1 and R2 are the equivalent.
Yes.
Yeah, same way you will check.
Okay, but and in some question they are asking what we have to add to make it functional dependency. Can you have some questions like that?
I think such a question was there in quiz 1. Did you have such a question in quiz 1? I remember making one.
No.
See, what this type of question is, either you will have the sets given to you, and in options it will be given like maybe in options A, B, C, D there are 4 different functional dependencies given. Okay, and the question might be that adding which one of these will make this equivalent. Okay, so in that case, what you can do is, like in this example only that I took right now. Wait, let me share the screen. It is sharing. Is the doc file visible?
Yes.
Okay. See, like in this question, okay, if I compared option C with F1, then which functional dependency is missing because of which these two are not equivalent? M determines J. So if I add M determines J here, then these two will become equivalent. Right? This is the type of question you're asking, no?
Ma'am, if you have the last PYQ, question number 14.
Okay, let me just once solve this question 9 from mock, then I'll solve that 14. Okay.
Ma'am, I have a question. In this last solved question, option B, can you check?
Option B. Okay, 1 second.
It is equivalent to the minimal set, correct?
Let me see.
And it is single select answer.
Option B, you're saying this one.
Yes, ma'am.
Okay, so this one is doing what?
Okay, sorry. I wrote it wrong. J goes to L. I wrote it as J goes to K. Sorry. Thank you.
No. Yeah, no problem. See, question 9 of mock quiz 2. Okay.
Yes, ma'am. In that, I am confused with the dependency preservation.
Yeah. Wait. Visible? Mock solution?
Yes.
Your dates are over, right, for mock submission?
Ma'am, there is no deadline for mock.
Okay. Are the solutions available to you?
Yes.
Okay, fine. Then we can discuss. When quiz 2 is tomorrow or what?
Yeah, ma'am. Quiz 2 is tomorrow.
Ma'am, tomorrow.
Okay.
Where we can find the mock solution?
In the portal only, it should be uploaded under mock solutions, supplementary contents or somewhere.
Ma'am,
This one, right?
mock section only. It was their solution.
Yeah, mock solutions. This question, right?
Yes,
okay. Wait, let me increase the size. So this is saying in the relational schema given below, all attributes take atomic values only. So R, bike name, bike model, bike engine number. Okay, these are the attributes of relation R. So suppose R satisfies the following functional dependencies. These 3 are functional dependencies of R. If R is decomposed into R1 and R2 like this, then the decomposition is lossy or lossless. Let's first find. Then we will see about dependency preservation. So what is the common attribute between R1 and R2? Bike model. So is bike model the key for any of R1 and R2? Bike model is the key for R2. Okay.
R2.
So that means this is a lossless decomposition, correct?
Right.
Now dependency preservation, let's see. In R1, what dependency is getting preserved?
Bike name
bike name to bike model.
So bike name
bike model
to bike model.
BM to
okay, and in R2 we get the dependency bike model
bike
BM to VE
to bike engine. number, whatever. Yeah, this one. So these two I get directly. Now, which one am I not getting? Bike engine number, bike name, right?
Right.
So if I, this one, this I have to find. So if I take this set, like whatever I have right now, if I take them together, so bike name, from bike name I can get bike model, and from bike model I can get bike engine number.
Bike
So
engine number
I can write that from these two I can write bike name
to bike engine number.
to bike engine number. But the reverse is what we want to find. And bike engine number also derives bike name. So how will I get that? So bike engine number, let's see what they have given in the solution is. Decomposition is fine. Closure decomposition. So bike name, bike model, bike name. From R1, they're saying that these two are possible. Okay. That bike name, bike model can be one, and bike model, bike name can be one. Okay. Now out of this, which one is in the actual set? This bike name to bike model, right? But these two are the possibilities. Similarly, in R2, these two are possibilities. Bike model to bike engine number and bike engine number to bike model. Right? These are the only two possibilities of functional dependencies, right?
Ma'am, but how? In
How
R1,
this
the
is?
second one, how can it be derived?
Yeah, it is not in the original set, right? But in R2, if I only say for R2, not saying the parent dependency set. Okay. Only for R2. What are the dependencies possible? These two only. Right. So if I write that R1 set of dependencies, okay, I don't know which are the valid ones. Okay, but what are possible? If you see, one tutorial is there actually that will help. Which one I forgot, but there is one tutorial in week 5 or week 6, okay, on dependency preservation. Bhaskar sir has recorded that. So there is one example like this, that if a dependency is like this, if there is a relation R1 having A and B, so possible dependencies here will be A arrow B and B arrow A. Okay, so both of these will be in the set of functional dependencies for R1. So if I take it like this, bike name, bike model, bike name, and this one for R2. Now union of all four.
Ma'am, but we have decomposed R1 and R2 based on the dependency already given.
The
Why we are
decomposition has
driving
been done.
new dependencies, assuming new dependencies?
New dependencies. No. What are the possible dependencies? See,
Yes, these
these
are assumptions
dependencies,
we are making. These are
these
possible.
dependencies that are given to us, right? These are based on this relation,
Right.
this entire relation. Now, once I break it down into R1 and R2, these can have new dependencies of their own, along with these already present. Okay, whatever dependencies are in the parent set, they have to be satisfied, right? So if it is a correct decomposition, then the dependencies will be preserved. But what are the chances, like what are the possible dependencies present in R1 and R2? So first you have to take that entire set. So these two are possible in R1, these two are possible in R2. Now you take a union of these two sets. So bike name, bike model, from which is the dependency that was not preserved? This one, bike name to bike E number, engine number. To bike E number. So if I take this set and this set, so bike name is present here in R1 set. So bike name to bike model, there is one dependency. And bike model to bike engine number, there is another dependency in R2. So taking a union of these two sets, I will get this dependency by transitivity, right? But yeah, I understand your confusion is that why we are considering these dependencies which are not there in parent set, right?
Actually, we have decomposed based on the model number, which is the common attribute. Now, if
Decomposition
we
is
are
done
getting
based on like not a particular attribute. Okay, decomposition is
because
done based on what normal form you're trying to achieve.
yes, ma'am,
All
but
of these factors.
if we see the split, model
Yeah,
number is
that
the
bike
common
model number is the common attribute, correct?
common attribute, and if with taking as a model number as a common attribute, it means it is a primary key for either of the table. It means it is primary key for R2.
Right.
So we cannot take consider that bike engine number will be
Yeah,
determining
because
bike
then
model.
bike model to bike name, if this is also a possibility, then it also becomes a key for R1. That's what you're saying, right?
Because engine number cannot determine bike model then, if we are taking bike model as a primary key.
See, in this decomposition, we are saying that bike model is basically the key for R2 according to our parent set of dependencies, right?
Right.
But if I take like whatever solution is given, if I do according to that, then if for R1, if I take the set of dependencies possible, then bike model will also become a key for R1, which is not true when we do decomposition like this.
Right. Bike model cannot be a key for
So they have
R.
written that decomposition of R is dependency preserving with respect to functional dependency F if closure of union of all functional dependencies with respect to each relation is equivalent to closure of F. So closure of union of all functional dependencies. This is what they're doing. So all possible dependencies set. Okay. So for R1 and R2, if there is one more decomposition R3, however many decompositions are there, R1 to Rn, for each of them you have to take all possible sets. So if there are 2 attributes, there are 2 dependencies possible. If there are 3 attributes, how many dependencies are possible? A good number of dependencies will be possible. Okay, so all of those dependencies are taken and closure is taken of, like union is taken of all of those. Now, if that union is equivalent to the original parent set, then they're saying it is dependency preserving. But okay, this question let me once discuss with Piyush sir and get back to you. Okay, because I
So,
also have a little bit of confusion that why I'm going to consider this
because
one.
I was very confused with this one, and it is not a
Because
simple
the way we
concept.
have been solving till now, we did not consider like this, right?
But
We took
I tried with ChatGPT, that also given that it is not dependency preserving.
okay. Let
Ma'am,
me.
sir has discussed this question.
So what did sir do? He said that this is the way to solve, like to take the union of all
Yeah,
possible.
I think the how you arrive those functional dependencies under R1 or R2 is take the closure of individual attributes in the main set actually.
But if I say, okay, if in R1, okay, bike name and bike model are present, right? So what are the possible dependencies here from the parent set? Bike name and bike model. So this is one bike name to bike model, nothing else, right?
Then
Ma'am,
you
but if we take
But
bike
if I
model,
take these two together, bike model to bike engine number and bike engine number to bike name.
if you
Okay,
take
then
the
from these two I can derive bike model to bike name another one.
yes, yeah,
Right.
that's how
Okay, this is how it has given, right?
yeah,
So this one comes from the transitive closure of parent set.
yeah
Yeah,
you have to
this is
take
yeah,
correct.
closure
This
of
is correct.
individual attributes.
Yes, because whenever we are checking what functional dependencies are like satisfying in a particular decomposition, that we will check using the parent set of dependencies only. Okay, so if I take these two together, then this is satisfying. Same for R2. So bike model to bike engine number, right? This is directly satisfying bike model to bike engine number. Other one, bike engine number to bike model. This how will it satisfy? Bike engine number to bike name to bike model. So if I take this one and this one, then by transitivity I can say bike engine number to bike model,
So
right?
if you do a closure of bike engine number, you will
Yes.
get the other
So
two.
the main what we understood is that whatever the decompositions are, you take all the attributes there and you check that okay, what all dependencies do these attributes satisfy on the parent set of dependencies, this set. So using transitivity you can see that all these are possible. Okay, these are not just taken arbitrarily, they are all satisfying from the parent set. So this is both lossless and dependency preserving. Is this clear now how this happened? The person who asked the question.
No, ma'am, I'm still confused. I will try separately.
See, I'll tell you one more time. So R1 has bike name and bike model, right?
Right.
So using these two attributes, just these two, from this parent set of dependence, this is the parent set.
Right.
From these two attributes, what can I derive? Bike name and bike model. So one is this dependency which comes directly, right?
Okay.
Now, if I take these two rest of the dependencies, bike model to bike engine number, there is one dependency, and bike engine number to bike name, there is another dependency. So using these two dependencies, transitively, I can get bike model to bike name.
Yes.
Okay. So even though this is getting transitively derived with the help of bike engine number in the parent set, but this dependency is not invalid, right? Bike model to bike name is a valid dependency. Right? So this dependency will also be present in this set.
Ma'am, but these are decomposed one, no? They have all.
Yeah,
They're all.
decomposed one, but decomposed based on what? On the parent set of dependencies. Everything you do is based on the parent set. It doesn't
Yes.
care that bike engine number is not present in R1. That is not my concern. Bike engine number is present in the parent set of dependencies. So using that, if I can transitively derive anything that satisfies in R1, so I have to take that into consideration. Whatever attributes are present in R1, any possible functional dependency that I can derive from parent set, even if that includes using other attributes which are not present in R1. So I will still consider those. Like bike engine number is not present in R1, but it is present in the parent set. And using it, I can derive this other dependency. So both of these are valid. So it will be present in R1's closure or set of functional dependencies. The key point is that whenever you are checking for functional dependency preservation, so take the attributes from the decomposed relation, but check using the parent set. Okay, don't just match that which dependencies are matching.
Ma'am, can you take a example of known dependency vis-a-vis?
No dependency is not preserved.
Not preserved.
Is that present anywhere here? As I said, I don't have any questions prepared from 5 and 6.
It's
so
in the slide.
Which slide can you tell me? Wait, let me check. One might be present. Actually, we mostly give dependency preserved questions only. Wait, decomposition. This is lossless.
So, ma'am, then we can directly mark dependency preserved.
Huh. No, wait. We actually, whatever previous year questions I got, mostly it was dependency preserved ones. So if you have any examples, you share with me because I currently don't have one prepared. Okay. Yeah. Any other question from mock quiz 2?
Ma'am, question number 16.
16. MVD question. Okay. MVD question is Piyush sir's part. Okay. Anyway, I'll try. Okay. So this is saying that consider a relation ABCDE with the following multi-value dependencies A to B, B to D. So suppose relation R contains tuples 0, 1, 2, 3, 4, 0, 5, 6, 7, 8. So which of the following tuples must also be in R? So what do you know about MVD? First tell me. What is multi-value dependency? This question, was anyone able to solve this?
So I selected
Yes, ma'am.
only one option. The other option I missed. Then when I saw when I clicked submit, then I realized what mistake I'd done.
So
Ma'am, I
like
tried this. I
anyone-
was able to solve this, but I was getting confused because either of one should be included.
So listen, first thing is you tell me, how do you approach such a question like this? In case of MVD, what are the rules of MVD that you know? Like how do I know that some dependency is multi-valued?
Alpha multi-determines beta.
Right, alpha multi-determines beta. So what is given to us? These two are present, definitely, right? So first consider these two tuples. 0, 1, 2, 3, 4 is 1, 0, 5, 6, 7, 8 is 1. Now we have to try to apply the MVDs, that is these two that are given to us, to any of the pairs of tuples. Okay, that will have the same value of attributes on the left side of the MVD. Right? So A to B, that means 0, 1. Okay, so which options should I check for?
Ma'am, just try to make the table with the options correct and then explain. I'm confused with that structure only. Because both of them cannot be included. Either of them can be included to make it MVD. But if both are included, then how it is making MVD?
Okay, these two are the original tuples, right?
Right,
Okay.
ma'am.
Yeah,
So
ma'am.
it is saying that each application of an MVD lets you add two tuples to the relation. So the tuples found by swapping the values for the attributes on the right side of the MVD. This everyone knows, right? That each application can let you add two tuples. This is not clear to you?
No, ma'am.
This can be done using formal definition of an MVD. So repeat this process until all the tuples implied by MVDs are already in the relation. So 0, 1, 2, 3, 4 is 1, 0, 5, 6, 7, 8 is 1. This is initially R, right? Now A multi-determines B tells us the following join to R. So this I can write. So 0, 1, this because A to B there is a multi-value dependency. So I can write it like this, AB and then ACDE. This I can write. So AB, what are the possible combinations? 0, 1 and 0, 5. And ACDE are what? 0, 2, 3, 4. Just this thing I have broken down into this way of writing because the MVD is between A and B. Okay, so 0, 1 and 0, 5. So R has at least the following set of values of which 2 are given and 2 are new. Okay. So R has at least the following set of values of which 2 are given and 2 are new, and one of them is 0, 1, 6, 7, 8. So this option it is saying. So how am I getting this option? So 0, 1, 0, 2, 3, 4 is 1. And 0, 1, 6, 7, 8 is 1. So what else can I add to this? I'm sorry, 0, 1, 2, 3, 4 and 0, 5, 6, 7, 8. These two initially I had. So keeping these dependencies intact, what else can I add to it from these four options? Can I take 0, 1, 2, 7, 8? Is that possible?
Ma'am, should we not change the B values and then try to add into the table and then see from the options?
Wait, come again. Change what values?
B values, like A is
okay, up to this is fine, right?
yeah,
Yeah,
ma'am.
ma'am.
Then what you are saying to write?
Change the
If
B
I
values.
write AB and ACD, this will remain like this. Okay. Now you tell me what do you want to write? One is this one. This I have to keep 0, 2, 3, 4.
Yeah.
So now what can I write after this?
Like the same. Now we will exchange 0, 0, 5, 0, 2,
And
3, 4. 0, 2,
correct.
3, 4.
And there will be another one for
Yeah, 0, 1.
0, 6, 7, 8.
Yes, ma'am.
And 0, 1.
0, 5.
I'm sorry, 0, 5. 0, 2. No, something I'm missing.
0, 6, 7, 8.
0, 6, 7, 8. Right. These are possible. Okay. Now, next they're asking that which of these must also be in R. So among these four, so how do I approach this at this point? B values you have changed, you have done all the combinations. Now, what is the next step?
Ma'am, we have to change D values also now.
Because there is one more dependency, B to D. Right? So B to D tells us what? That 1, 3. Okay, now write the same things, like the same, this part. Now I am just writing, instead of AB and ACD, I am writing BD and ABC. Okay. So BD and ABC, if I write, the tuples will change to what? 0, 1, 2, 3, 4. This was my tuple, right? So B values are what? 1 and 3 and 0, 1, 2, 4. And 5 and 7 and 0, 5, 6, 8. Okay, this is initially. Now, if I write the changed B and D, these values, if I write all the combinations, then what combinations will I get? One will be this 1, 3, 0, 1, 2, 4. Right, this is that first one. Another is 1, 3. Will I get any other?
Yeah, 0, 5, 6.
So for this, how many combinations are possible?
2
4.
combinations.
So R has at least the following set of this set of values. So if I now repeat A multi-determines B, it adds no new tuples, but B multi-determines D now gives this join. So 130124, 170168, 530524, and 570568. So one of the tuples that now join is, which is the new tuple that we got here? Which is the new tuple? 5, 3. Wait, this is BD. So 53068. That is present where? NVIDIA I haven't taught in so long. Even I am a little dusty on this.
Ma'am, this A multi-determines B and multi-determines D are two separate
Two
MBDs, right?
separate MVDs, yes.
So we don't have to apply it like simultaneously. It
No,
has
no.
to be separate.
One first you will do for A determines B like we did here.
Okay.
Okay. Then you see here that now after I do this, that A multi-determines D tells us that the following join to R, these two, right? So R has at least the following set of values. This is the following set of values that is present in R at least, of which 2 are given and 2 are new. So out of this, which 2 are given to us? This first one is given to us, and 0, 5, 6, 7, 8. This one is given to us, and these two combinations are new, right?
Yes, ma'am.
So out of this, which one is in your option? Only this one is present, 0, 1, 6, 7, 8. So this is one of the correct answers. Now this one I still haven't found because I still haven't checked for B multi-determines D. So now check for B multi-determines D. Here I get 130124. This is one combination. 570568. This is another combination. Okay. Because initially we have these two, right? These two tuples are present. So B and D values are what? 1, 3 ones and 5, 7 in this one. So for B and D, when we check for B multi-determines D, we get these two initially. Okay. So now check for the what other. So R has at least the following set of values. These following combinations will be there. So 0, 1, 2, 3, 4, 0, 1, 6, 7, 8. That we found from where? The 0, 1, 6, 7, 8 came from here, right? This has to be present. And then we have 0, 5, 2, 3, 4 that is present, and 0, 5, 6, 7, 8. So if I repeat this, A multi-determines B, is it adding any new tuple at this point?
No.
A multi-determines D. It is not adding. What is adding? B multi-determines D. So B multi-determines D gives what join? This will be the correct join for B multi-determines D. This 130124. This one is coming from this first one. Okay. Then 170168 from this second one. Then 530524. ABDE, ABCE, BD and ABC. Then 570568. So one of the tuples, what is the new tuple that you got here? That is present in this join?
05638, it is there.
So 05638 is present. So these two are the tuples that have to be present. So option B and option C. Okay. MVD, I would say.
How 0.05638? Can you please once repeat?
After B multi-determines D, okay, it tells us that the following join to R. So these two are the initial tuples that we have in R are what? 0, 1, 2, 3, 4 is one tuple.
Yeah.
Okay. And another one is this 0, 5, 6, 7, 8. This is another tuple. So B multi-determines D, right? So we broke down it and wrote it like this. So BD, ABC. So AB 0, 1, 2, 4. That is, this is BD, ABC. So 1, 3, 0, 1, 2, 4, 1, 3. B and D values.
Yeah.
And 5, 7. B and D values is 0, 5, 6, 8. So R has at least the following set of values. So I know that R definitely has the first tuple. Okay, this tuple, and what other did we get from A A multidetermines B, that 0, 1, 6, 7, 8 must also be present. Right?
Yeah.
So 0, 1, 6, 7, 8 is also there. And what else? 0, 5, 2, 3, 4. That also we got here. 0, 5, 2, 3, 4.
Yeah.
So these have to be present. Now A determines B. A multidetermines B. Adding no new tuples. So using A multidetermines B, we can add no new tuples. But B multidetermines D gives this join. So how did we get this join? This join, how are you getting it?
By changing values of D.
By changing values of B or
D.
D, right? So what are the
D.
possible combinations? One is
1 3
6 1 3 1 7.
okay. Another is 1 7 0 1 6 8. Fine, that is coming from here. Then 0 5 2 3 4. So this gives 5 3 0 5 2 4. And from here I can get 5 7 0 5 6 8. So 0 5 6 3 8. This is one of the tuples that in that join. So 0 5 6 3 8, if I add it here, 0 5 6 3 8. So this would be 5 3.
This is from B multidetermines D.
B multidetermines D, correct.
Okay.
0 5, and then C is 6,
8.
and we have this. So this is also one of the combinations that will be there. If we keep on changing the D value, this is also one of the combinations we will get, right? Here.
Yeah.
Not all of them are written. See, these dots are given here. So like this, we have to check for all combinations in case of MVD. So this will be one more combination. So for this new tuple will be added to this. ABCD.
And what other types of combinations are possible? Like any one
We have to change all the D values here. Like whatever are the possible combinations because of B multidetermines D. So these are present here.
These are only possible in case of B multidetermines D, right?
Yes, but from this set, check. From on here we are checking, na. So from 0 1 2 3 4 we got 1 3 0 1 2 4. From 0 1 6 7 8 we got this. From 0 5 2 3 4 we got this one, and from last one we got this. So R has, then it should be this option, no?
Ma'am, the way I approach it's become very easy and we can find easily the answer.
Okay, tell me what way did you do this?
So first of all, it is given like
So A determines B, it is fine. Then B determines D. This part. Yeah, go on.
First of all, you should write a ABCD, right? And you should write that things 0 1 2 3 4 and 0 5 6 in 2 row, and after that
0 1 2 3 4 is one row, and 0 5 6 7 8 is another row, right? These two are initially given to us.
Yeah, just now exchange the like here it is determining A, determining B, isn't it?
A multidetermines B.
Yeah.
Yes.
So now just exchange these two B column.
So if I do 0
0
5 2 3 4 and 0 1 6 7 8. This one we got. Yeah, this is fine. This I got, but for B determines D. This one I
Yeah, you will get again same way, ma'am.
So here also I will start with these two only, 0 1 2 3 4 0 5 6 7 8, and these two.
Yeah.
So I'll take all four combinations.
No, ma'am. You can
Only
do from
first
here.
two I'll take, no? 0 1 2 3 4 and 0 5 6 7 8. Now B and B multidetermines D. So there should be combinations like 1
0 1 2 7
0 1. Now
2
we are
7 4.
exchanging B and D. So 0, if I do this, 5 and 7, so 0 5 2 274 should be 1. Right?
No, ma'am. No, ma'am. It will become 0, 1, first row, 0, 1, 2,
We are taking
7.
B and
No, ma'am, you are doing it in a correct way. 05274 and 01638 will be the two rows. We'll get
yeah,
when we
because
do
you are exchanging B and D.
Yes, yes, ma'am.
So 05.
Ma'am, we can exchange right hand side, only right hand side, not left hand side,
So,
because it is multi determining D only.
so 01274. This should be 1.
Ma'am, the other one is 05
638. Yeah. This is how we are getting 05638. So since we are having multi-value dependency, B multi-determines D. So only D values we have to exchange.
And from the last two tuples of A multi-determining B, we'll also get 05274.
Right, 05274 also we'll get.
And 01638.
Like from these two you're saying, no?
Yes, ma'am.
Yes, ma'am. We need to do
Here also, if we exchange, then I'll get 05638 and 05638. This is. And
No, there we'll get 05234 because 05638 we already got.
No, this is using B multi-determines D.
Yeah,
But-
using B multi-determines D on the tuples we got from A multi-determine A. So we'll get
from these last two tuples, we can get these two. 05638 and 101274.
No, these are from first two tuples by exchanging only D values.
Yes,
And
ma'am.
then
From these two, if I exchange D value, then I'll get these two, right?
Yeah.
This is okay. And again, when I was doing for A multi-determines B, then also I did for these two only, initial two tuples.
Yeah, now we'll take last two tuples.
Last two
So
tuples from
basically, ma'am is changing one time for B, one time for D. That's it.
Yeah, that is what I said. That one time I'll change for B, one time I'll change for D. I don't need to do this again, no?
No, we'll get one more tuple, 05274.
That is by exchanging from
Last
these
two tuple, D values in last two tuples. Yeah.
D values in these two tuples, right? So 05274 will be 1.
Yeah. And one will be 01638.
01638. Yeah.
Yeah.
Right. This will be 1.
These are all the tuples we'll get.
But among these in options, we got only these two, so these two will be marked. Right. MVD, did I take the MVD class this time? No, I think Piyush sir did, no?
Piyush sir took it, ma'am.
Yeah. MVD questions also I don't make, so.
Yes, ma'am, but we can do it with the five equality theorems are mentioned in the slide. That will be.
Yeah, that was enough. See, in MVD, main thing that you need to remember is that whatever is getting multi-determined, like if alpha multi-determines beta, then we have to check for all combinations of this beta. Okay, not both. So for beta, like here I checked for B multi-determines D. So I took all the possible values for D, exchanged them, right? And we got the desired tuples. There are 2 or 3, no, I think 5 total set of rules present in one of the slides it is given. Okay, there is one question from previous year. You will see it is from some cafe type question, like some coffee, tea. Using that, some MVD question is there. Okay.
Ma'am, excuse me.
Yeah.
Ma'am, from previous, this one March 24, if you can check question number 4, it will be helpful for the MVD. Have a look over it, please.
Question 4 from?
From the last, this one, March 24 only. March 24 exam. I don't know how to share this.
March 24 means Jan term quiz 2, right? Okay.
Yeah.
Let me check. What is the time? Oh, I have a meeting from 11:30. Okay, fine. Let me check.
Ma'am, I shared the link.
How to study also.
Okay, which question from here?
Ma'am, one question is there. A B C D sample question number 4 6406365377109 is the question
Got
ID.
it.
Your screen is not visible. Like.
Yeah, wait, I'm sharing. One second. If I knew that you people had doubts regarding these topics, then I would have prepared the questions and all. Okay. Is it visible?
Yes, ma'am.
This is the one, no? So it is saying if the functional dependency B, one second. So this is saying if the functional dependency B determines C and multivalue dependency A multi-determines BC hold on the table sample, what will be the values of X, Y, P, Q? So B determines C if it has to hold, then B1 determines C1, B. So basically B2 should also determine C2, right? This B2, that means this X should be C2 in order for B determines C to hold. Yes or
Yeah.
no?
Yes.
Right. So definitely X has to be C2. So this option is eliminated. Now, multi-determined multivalue dependency is what? A multi-determines BC. That means A1, B1, C1 is there. A1, B2.
I'm sorry to disturb you now. Now you have two rows. A1 first two rows A1 B1 C1 D1 and second row A1 B2 C
D2.
C2
Yes.
and D2.
Yes.
But according to you, sir, you just whatever the attribute given, like B and C has given, you just exchange them. So another row will become A1 B2 C2 D1 and A1 B1 C1 D2.
A1 B2 and C2
D1
will be 1.
Yeah.
And
Then A1 B1.
Wait, 1 second. A1 B2 C2 D. Sir said to take combinations for which values?
Ma'am, sir said that we have to
B and C you just exchange.
right hand side one.
Like these values to exchange, right? B and C values.
Yeah. So next will be
Yes.
the A1 B1.
So C1 D2.
Yeah. So now the
This
other
is
two rows. Yeah, this
this
is the answer. Like that they are telling.
easiest way to solve this. So now you got X is C2 and Y is D1. P is B1
B1.
and Q is C1. Yeah, this is actually the easiest way to solve this question. This is correct because on the right hand side of the multivalue dependency you have two values. Now B and C are two different attributes, so you have to take the like both combinations. Like once this one B1 C2 and once B2 C1.
Yeah, and the one previous question you are telling, in that one only problem is happening. That one B and C are like A to B, B to D given separate times.
There are two different dependencies. No? So
Yes.
we have to check.
So we have to do it one by one.
Yeah, one by one. First for A multi-determines B, you have to find all possible combinations. Then again for B determines B multi-determines D. This is much easier question than that one.
Ma'am, ma'am, in the previous question that you solved, so ma'am, like the new tuples which we got from A multi-determining B, we have to change the values of D now from the new tuples that are added also.
Yes, there will be more combinations. You're asking that after I wrote the combinations, will there be more?
No, ma'am. I'm saying that after there are two dependencies which are given, like A is multi-determining B. So we
Let me
created a
share that. 1 second. I think I lost that question. Wait. Yeah, I lost that question. Okay, you ask what you're asking.
Ma'am, I was saying like we got the new tuples after exchanging the values of B. So now when we will exchange the values of D from the tuples which we added also, no?
Yeah.
Not
So after the values of D, since B multi-determines D, so you have to change the values of D in the second part of the question.
not from the only the two rows which were given.
Yeah, from initial you are doing those from those initial two rows only. Okay. Then once you have done, like then you got 4 rows, na, in total.
Yes, ma'am.
So you're asking that after that, do you need to again exchange the values of D?
Yeah, ma'am. Like the new tuples which we are created from the A multi-determining B. We got the new tuples. So do we need
But I think no, I don't think you need to do that again.
Ma'am,
You're getting the desired all the values, right? All possible combinations. Wait, let me share that. Got it.
ma'am,
Yeah. So this one, yes, Suraj, yeah.
I have posted the YouTube link. Piyush sir had
Yeah,
solved
Piyush sir has solved this MVD once in 2022
22.
term, I think.
Yeah, it's in that YouTube link
Yeah,
actually.
check that route once because mainly Piyush sir takes the MVD part, so he has solved this better, I guess. So you check out this link once. Anyway, the question she's asking is that after I got these 4 combinations, right? Bhumika, this is what you're asking. These 4 combinations I got. Then you're asking that do I need to further change the values of D?
no, ma'am. From the last two rows of A multi-determining B, like 05234 and
These
01678.
two. These
Yeah,
two.
ma'am. Because like we need to change from the original two tuples or the new tuples which are also added.
If I change from here, if I change the value of D from here. No, from the new tuples. From the new tuples we have to change. Original we already did. Originally these two were present. Now A determines D after doing for this we got 2 new tuples, these two, right? Now you're saying that from these two tuples do I need to again change the value of D for B determines D, right?
Yes, ma'am.
Yeah, you can do that. So that will give you all possible combinations. But out of these, whatever is in the options you have to choose from there only. So that you already get from this too. So there is no need to do it for this question. Because in your options only these two are present. Still, I would say that it is better to check out this link that he has shared in the chat box because Sir has solved this question in a very better way. So just check out this YouTube link once. Okay, he has pinned this. Okay, now listen. Before I
Ma'am,
end
could
this,
you please solve last question?
consider a disk having 128 tracks per surface, 512 sectors, 256 bytes per sector. If the minimum number of bits required to access a sector is 22, number of platters required. Yeah, see, I'll tell you how to do this. So, bits required is 22. That means how many total number of sectors are there? 2 power 22?
Yes.
Right? So, 2 power 22 into 256. This is the disk capacity.
Yeah.
This many bytes. So, now you know that number of platters is what? Just take P as the number of platters. Okay. So, P into the disk capacity is 2 power 22 into 256 equal to. You have to write number of platters as P or take whatever you want into total number of sectors. Okay, I'll write this down. Just tell me the data, someone, because I can't see that screen. Just tell me total disk
We have
capacity was 2 power 22 into 256 bytes, right?
Yeah.
And number of platters I need to find.
Yes.
So
So platters we can find just from like
yeah,
total
just
number
take
of
it P into, then do that whole thing, whatever is given there, number of
yeah
tracks, number of
Ma'am,
sectors.
we
P
don't
into
need the 256.
yeah
That data is extra, right? That we don't need
Yeah,
that.
this is actually extra data. You don't even need this. Yes.
we just need number of sectors on one platter uh, divided by the total number of sectors,
Because
that
anyway,
is
this
2 to the power
256 will get cancelled out on both sides if I write
10. Yeah.
this. So just number of platters into number of tracks into number of sectors, this whole thing. And from there you can get P's value, that is number of platters. Okay, but
Yeah,
Okay,
one
ma'am.
more thing is that if it is mentioned like the surface and all, if that is mentioned, then you have to multiply with 2 also.
yeah.
Okay. Yeah.
So number of sectors on one platter, I mean a total number of sector divided by number of sectors on in one platter. That will give the
That
number
will
of
give you
platters.
number of platters, correct? Yes.
Yeah.
Ma'am,
Okay, so yeah.
ma'am, will there be questions from mean time to failure and like MTTF?
See, there are maybe 1 or 2 questions in your practice assignment, na? It is given like what is MTTF.
Yeah,
One
ma'am.
or I think 1 or 2 questions are there in practice assignment. That is enough. Okay, nothing more. Just do those 1, 2 questions, whatever formula is given. That's it. Nothing more. I would say that much more important for quiz 2 this term is this type of questions. This number of sectors, disk capacity, transfer rate. Okay, transfer rate is very important. That remember that
Okay.
kb per meter second. That one I did.
Yeah, ma'am.
Millisecond, kb per millisecond. That type of question is very important.
Ma'am,
So let
transfer rate is always we find for one sector and then multiply with total number of sectors, right?
yes, yes, yes.
Okay.
Transfer rate. See all those formulas I gave you in when we were doing the class. But let me quickly
Yeah,
tell you
ma'am.
what are the important topics for quiz 2 this term. Okay, wait, because I have to leave soon. So if you still there are more doubts that you have, okay, just post it on Discourse. Today we will solve them on priority because tomorrow is the exam, right? So you just
And
tag
when
us.
the formula sheet, please post it now. Better, otherwise you will
Yeah,
forget
formula sheet
later.
I'll give now only. I have to find that where it is, but I'll post in 1 or 2 hours. Okay.
Yeah, please, ma'am.
Yeah,
Thank you
ma'am.
so much, ma'am. Have a nice day.
Yeah, you too. All the best. Okay, let me give you the important topics. Wait.
Ma'am, where will you post the link for
Discourse.
Discourse? Okay.
Yeah. So, can you see like my screen is visible or?
No,
No,
ma'am, it
ma'am.
is not.
No, ma'am.
Okay, good. You don't need to see my screen.
Oh, question paper.
No, no, not question paper, but yeah, I have a list of what are the important things, but don't want to discuss too much. So, wait. Where is that list? Okay, yeah. So, like I said, the formula sheet that I will be pasting, okay, all the formulas from there are important for quiz 2, all of them. Like that average rotational latency, all of these things. Okay, transfer rate. Then from your weeks 5 and 6, I would say canonical covered is one of the most important things. Then total number of, okay, those questions are discussed, right? How to find maximum number of super keys.
Yes, ma'am.
Okay, that 2 to the power m minus n, those formulas have been discussed.
Yeah, ma'am.
Yes, ma'am.
You also know that if there are more than one candidate keys, then how to find.
Yeah, ma'am.
Yes, ma'am.
Okay, then you have to do that formula n of a plus n of b minus union, that whole thing.
Yeah,
Okay,
ma'am.
these things are important. One more thing is normal forms. Okay, 3NF, BCNF important. 4NF is also important, obviously. Okay, from your week 7, whatever I discussed today and whatever Piyush sir has discussed in the session, okay, SQL injection part has been discussed.
Not during the
No, not revision, but in week 7 it must have been discussed. Okay.
Yes.
So SQL injection is an important topic.
Ma'am, SQL injection is that thing, right? We execute that query.
Yes.
Okay.
Sorry. Yeah. Then BST is important, right? Binary search tree is very important. This buffer LRU, that is important. And what else? Okay, Armstrong's axioms. Yes, Armstrong's axioms is important. Please remember what all the axioms are. And okay, equivalence of FD sets that you know how to find, and obviously that lossless and lossy decomposition. Okay, these are all the topics that are important. From 5 to 8 only, I told you. Now 1 to 4, you already know. You have given quiz 1. You know what are important.
For 5 and 6, what did you told? Can you repeat, please?
5 and 6, normal forms, MVD. Okay, Armstrong's axioms, canonical cover, equivalence of two FD sets. These are all important.
And ma'am, decomposition in the normalization
Decomposition, yes. Lossy, lossless, and obviously which one is in which normal form. Those type of questions that we have all solved. Yeah, these are important. And from 1 to 4, you know what are important. ERD is important. Relational calculus, relational algebra, that part. Okay, but relational calculus, don't get too carried away. Just do whatever we have practiced. That is enough. And week 2 and week 3 mainly focus on the SQL questions, like the keywords, like exists. What other keywords did we have? Any,
Yeah,
all these. Okay, exist, not exist, this type of things. Week 1, I won't say anything. It is very trivial. So other than that, these are all important.
Ma'am, what are the important topics from week 7 to 8?
Yeah, week 7, I told you, whatever is done in the session, just that. And whatever, like what kind of questions I took today, very basic things like what is missing in this piece of code, why it is not running, what is fetch all, fetch many, that thing is important. Just whatever Piyush sir covered in the session. And if you want, just go through the slides once, but no need to memorize all the theory present. Okay. But yeah, weeks 5, 6, a lot of weightage is there. So please be prepared for that. Yeah. Okay, that's it from my side. Thanks for joining all the vets for tomorrow.
week 8, like theory questions won't come now. Only the
What?
week 8 theory, ma'am, theory part.
Week 8 theory.
Yeah, ma'am.
Week 8 is mainly based on numericals. Week 8, what theory is there in the slides? Like all this, you are saying that magnetic disk theory part.
Yeah, ma'am, and other is also there, like from 8.1 to 8.2.
No, like don't memorize all of those. Okay, that what is the timing complexity, all of those things. Just whatever we have discussed in sessions is enough. Okay. You can go through all the slides or a professor's lectures, but you cannot memorize all this material. It's a lot. It's not possible. So week 8 is mainly important for numerical type questions. Okay.
Ma'am, please can you check the chat box once?
Yeah. Whose question? Khushi Chaudhary, this one.
Yes, ma'am.
And we use Armstrong's axioms if we are checking to find highest normal form. So with given FD, we are getting highest normal form 2NF, but we take transitivity, such a dependency form that makes the violating attribute as prime attribute or super key. See, Armstrong's axioms, I would say it is better to find if you want to find highest normal form. Na? Instead of, if you use Armstrong's axioms, it might be possible to find, but it is a lot of work. And at that exam time, you won't have that much time to check with all the axioms. So anyway, we won't give you a very big FD set. It will be a moderate small FD set only. It will be much easier to check for transitive and partial dependency the way we have taught in class. Okay, that look for what is partial dependency. That What is partial? Anyone?
Yes, ma'am.
Proper subset of candidates.
Proper subset of so.
The proper
Proper
subset of
subset of
candidate
candidates.
key is deriving a non-prime attribute.
Non-prime.
So this checking this is much easier. Okay. And for non-prime, for third normal form, what is it? Transitive dependency. So obviously transitivity is, you can check using Armstrong's axioms. All of these are related. You can use any method, whatever seems easier to you. Okay, but I would say that in case of exam point of view, this is easier to solve like this. That
And
just
what kind
find
of
the
questions
candidate.
can come from the Armstrong axioms?
I can't tell you what type of questions. Just go through previous years, but Armstrong axiom is an important topic. Like knowing what all the axioms are. What is transitivity? What is pseudo transitivity? You have to know the definitions. Okay.
Okay,
If you
got
know
it, ma'am.
what they do, then you can answer.
Okay, got it, ma'am.
Okay. Yeah. All right. If there isn't any, if you have any more doubts, okay, any other question, activity, practice, whatever you find out later on also, just post today. We will answer on priority today on discourse. Okay. Just tag the TA or any of us.
Okay,
Fine?
ma'am.
Okay.
No
Thank you,
Thank
ma'am.
you.
Thank you,
Thank
ma'am.
you.
Thank you, ma'am.
Thanks a lot, ma'am.
Thank you.
All right.
Thank you, ma'am. Thank you.
Just don't forget the formula sheet,
Yeah,
ma'am.
yeah. I will upload it. Yeah.
Have a nice day.
Okay.
Thank you.
Thanks.
Ma'am, you will pin it, na formula.
Yes, I'll pin it.
Thank you, ma'am.